Hello, I'm Doug Jones with Michelin North America. Michelin is committed to safety when servicing tubeless radial truck tires. So we've partnered with the Tire Industry Association to bring you this very important message. We're confident that if you follow the safety procedures outlined in this video, you can reduce the risk of an accident and protect yourself from a serious or fatal injury.
A tubeless radial truck tire inflated to 100 psi contains enough explosive force to launch a 16-pound bowling ball almost 3/4 of a mile, or 13 football fields. Since the risks to dealer and fleet personnel who service these assemblies are potentially fatal, the Occupational Safety and Health Administration created regulations for employees that handle truck tires and wheels in any way. OSHA Regulation 29 CFR 1910.177 contains the proper procedures for demounting and mounting tubeless truck tires on single-piece rims and includes specific requirements for the equipment used to inflate tubeless radial truck tires. OSHA regulations also require safety glasses and other forms of personal protective equipment, such as safety shoes or boots. Before attempting to demount a tubeless tire, remove the valve core to completely deflate the tire. Once the tire appears to be deflated, run a wire down the valve stem to make sure it is not plugged. Using a slide impact tool, unseat both beads on the tire. With the beads unseated, lubricate both bead surfaces with an approved rubber lubricant and avoid petroleum-based products. In order to demount a tire on a single-piece rim, you must determine the short side of the drop center. On steel 22.5 and 24.5-inch disc wheels, the short side of the drop is opposite the disc. A rubber mat should be used to protect the mounting surface on all disc wheels.
On 22.5 and 24.5-inch aluminum wheels, the tire can be demounted and mounted from either side. But tires on 19.5-inch disc wheels must be demounted and mounted from the disc side.
With the beads thoroughly lubricated, position the tubeless tire irons on either side of the valve stem approximately 6 inches apart, with the stops facing in. Lift the tire irons to pry the bead over the rim flange, making sure the opposite bead is fully in the drop center. Remove one of the bars and position it just below the spot where the bead contacts the rim flange. Push the curved end of the bar between the rim and bead, making sure the tip is completely below the bead toe. If the tire iron is not properly positioned, it can damage the bead. The end of the bar can tear the bead sole under the force of prying the bead over the flange. This type of damage can be prevented by making sure the tip is completely below the bead toe. With the tire iron properly positioned, pry the bead over the rim flange. You may need to remove the other bar and repeat the process several times to completely remove the top bead. Lift the assembly and position the flat end of the tire iron between the rim flange and the back bead. Make sure the tab is past the rim flange to prevent the bar from slipping out. Allow the assembly to fall to the ground while pulling up on the tire iron to remove the bottom bead. Before mounting any tire, make sure all of the components are thoroughly inspected. It's also a good practice to install a new valve stem when mounting a new tire or retread. Perhaps the most important step when mounting a tubeless tire is to lubricate the rim surface and the beads with an approved rubber lubricant.
Make sure you cover the entire bead surface from the toe to just below the molded ribs on the sidewall.
Position the tire opposite the valve stem and push down to begin the mounting process. Place the curved end of the tire iron with the stop facing down between the bottom bead and the rim. Start with 1 foot inside the wheel and step outside the assembly while prying the bead over the rim flange. Once the bottom bead is mounted, reposition the tire so the sidewall opposite the valve stem is closest to the drop center. Next, stand on the sidewall opposite the valve stem with your feet approximately shoulder width apart. Place the curved end of the tire iron with the stop facing down between the top bead and the rim. Lift the bar to pry the top bead over the rim flange. Make sure you don't move the foot opposite the bar when you mount the top bead. Before removing and repositioning the tire iron, move the foot closest to the bar. Continue the process to mount the top bead. After the tire has been properly mounted, the beads must be seated. In order to make sure the beads are evenly seated on the rim, the best practice is to seat the beads with the assembly in a horizontal position. When the beads are seated with the tire in a vertical position, the weight of the rim can result in beads that are not centered on the rim. As you can see, the distance between the rim flange and the molded rib on the lower sidewall is different around the tire. This results in lateral runout, which can cause a vibration or irregular tread wear. If you look at this tire from a cutaway perspective, the heel of the bead is curled under, which causes the bead toe to lift. Real-life examples can be prevented by a combination of clean rim surfaces, proper bead lubricants, and horizontal bead seating. When properly seating the beads, a tire stand should be used to suspend the rim so the sidewalls are not touching the ground. Once the assembly is in the horizontal position, the valve core should be removed. If the valve core has already been removed, run a wire down the valve stem to make sure it is not blocked. Since the beads do not always seat on their own in this position, use a bead blasting tank or similar device to release the compressed air and expand the sidewalls of the tire so the beads become seated. Never use any type of flammable substance such as ether or propane to seat the beads on any tire. After the beads are sealed, the assembly must be checked for concentric seating. If the distance between the rim flange and the sidewall rib varies by more than 2/32 of an inch, the tire should be deflated and demounted to determine the problem. If the rim has been damaged by excessive heat or overloading, it may be too small for the diameter of the beads. If you suspect this type of damage, deflate the tire and remove the rim or wheel from service. To protect you from the dangers of this and other conditions, OSHA regulations state the maximum inflation pressure to seat the beads outside a restraining device is 5 psi.
Before attempting to inflate any tubeless radial tire on a single-piece rim, make sure you understand the OSHA requirements for all truck tire inflation devices.
The first required component is a clip-on air chuck. Clip-on chucks come in a variety of different styles, and by design they are not permanently attached to the valve stem. Air chucks that require the technician to hold the device on the valve stem and those that are screwed on using the threads are not considered OSHA compliant. In order to prevent the accidental overinflation of a tire, OSHA also requires the use of an inline valve with a pressure gauge or a presettable regulator. The inline valve allows technicians to control the airflow to the tire, and the built-in pressure gauge makes it possible to check the inflation pressure without approaching the assembly. Presettable regulators make it possible to simultaneously inflate multiple tires to the same, or in other cases, different inflation pressures. As long as electronic inflation equipment can be set so it cannot exceed a specific pressure, and all other OSHA requirements are met, it can be used to inflate truck tires. The next component for an OSHA-compliant inflation device is a sufficient length of hose. While federal OSHA does not specify the length of the hose, it must be long enough to keep the technician out of the trajectory area of the tire throughout the inflation process. But the most important component is the restraining device, also known as the safety cage. The sole purpose of the restraining device is to prevent the components or assembly from becoming projectiles should they separate during the inflation process. Tubeless radial truck tires can suddenly lose inflation pressure for a variety of reasons, and the restraining device prevents the assembly from being thrown outside the device, no matter how the force is transferred. That's the main reason why restraining device manufacturers do not recommend bolting cages to the floor. When the force is transferred from the tire to the device, the heads of the bolts could snap off and create additional projectiles. The best practice is to position the restraining device in a clearly marked area at least 1 foot from any flat, solid surface. If more than one restraining device is being used at the same time, equipment manufacturers recommend at least 3 to 5 feet between the cages. Before placing any truck tire and wheel assembly in a restraining device, technicians should carefully inspect it for any damage that may decrease its effectiveness. This includes cracks at the welds, cracked or broken components, bent or sprung components, or severe pitting from corrosion. If any of these conditions are present, the restraining device must be immediately removed from service.
By visually inspecting restraining devices on a daily basis, you give yourself and your fellow employees an added layer of protection if a damaged tire suddenly releases its pressure during inflation. The final step in the truck tire inflation process should always include a restraining device. Technicians should know that most of the serious and fatal injuries that are associated with a sudden release of pressure occur when the tire is being inflated outside the safety cage.
With the beads properly seated and the valve core still removed, the tire and wheel assembly should be placed in an approved restraining device. Using an OSHA-compliant inflation system, begin to inflate the tire and listen for any popping sounds. In order to identify any potential signs of weakness or irregularity, the assembly should be carefully inspected at 20 psi. While inspecting the tire, do not place your hands inside the restraining device or position your head near the sidewall of the tire. Look for bulges that may indicate a zipper rupture or any other type of damage that may result in the sudden release of pressure. If any of these conditions are present, the tire should be made unusable and scrapped. Zipper ruptures are typically identified by the popping sound that the damaged sidewall cables make as they break during the inflation process. Studies have shown that most zipper ruptures occur between 20 and 120 psi. But their unpredictability and resulting effect on the restraining device can cause serious injury if technicians are in the trajectory of the assembly during inflation. Rims that have been damaged by excessive heat can also result in the sudden release of inflation pressure. For these reasons alone, you should always make sure that you are a safe distance from any truck tire being inflated in a restraining device. That's also why you should inflate truck tires with the valve core removed, so the assembly can be deflated without approaching the trajectory area. On new radial truck tires, inflate the tire to the recommended fleet inflation pressure. If that pressure is not available, inflate the tire to the maximum pressure listed on the sidewall. After installing a new valve core, verify the inflation pressure with a calibrated air gauge and adjust the pressure if necessary. A checking station should be used on a regular basis to verify the accuracy of air gauges. On all radial truck tires other than new, such as used, retreaded, or repaired, the tire should be overinflated to 20 psi over the maximum inflation pressure listed on the sidewall. When inspecting a radial truck tire for a zipper rupture, never inflate the tire beyond the maximum inflation pressure stamped on the wheel or rim. If the tire does not show any signs of a zipper rupture during the overinflation period, deflate the tire, install the valve core, check the inflation pressure, and adjust it to fleet recommendations or the pressure listed on the sidewall. The final step is to install an inflate-through metal valve cap or a standard metal valve cap to protect the valve core from dirt and corrosion.
We hope this information on Tubeless Radial Truck Tire Service will help you create a safer working environment in the shop and improve safety on our highways. On behalf of Michelin North America, I'm Doug Jones. Thanks for watching.